What we're doing here is chemical recycling of this water bottle. So we have an instrument that can shred and like cut into small pieces, right? That polymer. And then we have like a high pressure reactor that like we load that material inside, and then by using like catalysts and solvent and some other like ingredients, you can break down that polymer to smaller molecule. Like you can produce starting materials like some organic materials that you can use to synthesize this polymer again for other products. You know what I mean? So this way, we call it like chemical recycling. In contrast to like mechanical recycling, where you just melt the polymer and reshape it. So this way, we can have control over like the chemical structure that you can get from this polymer. And as I mentioned, we can find like lots of uses for it. As you can use that product in so many applications. One of them would be synthesizing the same polymer again. We're also like working on like making like some bioplastics by using some biomaterials. Like one thing that Bahar is doing here is extracting of keratin from chicken feathers, and those can be used to make like these are feathers, right? Yeah. So these are literally like poultry feathers. So feathers from like chicken or ducks. So since these are like biomaterial, they degrade much faster in the environment. Sometimes this polymer takes like 400 years or even more if you leave it in soil. If you dump it in the land, it would take 400, 500 years to degrade. And that's why it's with that. We shouldn't leave these in the environment, right? Because they start coming back to our feet. So that's bad. By using something like that, which is biodegradable, you can make a polymer that degrades like pretty fast, less than 1 year in the environment. Even if you dump them in the ocean or the soil, they can be like degrade like pretty fast, and the products of that degradation is not harmful for the body. But this polymer can be dangerous, like can be toxic for our body. That's why we don't want them in our food.